What's going on? My name's Robert, and you are watching Southpaw Auto Works. Have you ever wondered how the 4L60E pump actually works? Like, sure, maybe you have a general idea of how it works. You know, it sucks fluid in and pushes fluid out, but how does it do that? This pump happens to be variable displacement, meaning it can output more or less fluid depending on the demand of the transmission and, of course, the engine. In this video, we're going to cover the basics of how the pump works. We're going to go into the more advanced stuff of how the variable displacement or variable output works. We're also going to cover all of the responsibilities of the pump, and it's got a huge weight on its shoulders. Without further ado, let's dive in. Here's the pump out of a 4L60E automatic transmission. This one happens to be an early design. It's actually the earliest of the early designs. Specifically, it's specifically a 93, and you can tell by the casting number on the back side of the pump. The pump is actually two halves, a front half and a rear half that are sandwiched together. And then you've got this tube that runs through the center of it. And we'll get to each of those components here in a second. As you can see, there are a number of holes around the outer edge of the pump. A handful of these holes are for the pump bolts, and these bolts are the pump to case bolts, so these bolts secure the pump to the transmission case. Speaking of bolts, these bolts here hold the pump halves together. So the other holes that aren't used for the pump bolts are actually used for oil passageways. You've got a number of oil passageways that are exits out of the pump, and even more that are entrances back into the pump. This tube here, also known as the stator shaft, this tube has holes on it on the outside and a number of holes down inside of the tube. All of the holes provide a pathway for the oil to travel from the pump to the valve body, from the valve body to the clutches, etc. There's a number of openings around the outside edge of the pump. Here we've got the torque converter clutch valve train, the suction port for the pump. Your filter actually hooks right into this. Your pressure regulator valve train. This is a filter that lives inside the pump in the line pressure port. And this is the pressure relief valve train. And then all these other little holes on here, those are all cut plugs. If you follow this passageway up, it's running this direction, and then yet the fluid turns 90 degrees. So what they did was drilled a hole in this direction, and then in order to get it to go that way, they had to drill right through the side of the casting, and then they blocked this hole off with a cut plug. Let's get to the good stuff and open this pump up. Like I said before, the pump is comprised of two halves. This half is the pump cover, and it includes this hollow tube known as the stator shaft. This half of the pump is the pump body. Normally, we'd have two springs, an inner and an outer spring down in here. And that pushes this slide to the right. This is our vane-style pump. This one happens to have 10 vanes. Later 4L60E models have 13 vanes. The pump is driven by the torque converter. Anytime the engine is running, the torque converter is bolted to the engine. So the torque converter rotates with the engine. This torque converter hub has lugs on it, or splines, and it splines to this pump rotor, which sits in the center of the pump assembly. The pump rotor holds each of the vanes, so as the torque converter rotates, the vanes rotate. This ring is called the pump vane ring. There's two of them, one on top and one down below that we can't see. The job of the pump vane ring is to keep the vanes pushed outward up against the inside of the pump slide. Now, how does this pump create suction? If we look in between any two of the vanes, let's pick these two here. Between those vanes and between the inside of this pump slide and the outside of this pump rotor, we've got a little cavity there. We're going to call it a pocket or a chamber. That pocket is sealed on all four sides, and it's also sealed on the bottom and sealed on the top if we had the other pump half bolted onto here. But if we pay attention to this chamber, as it rotates around the pump, the chamber grows. But then we get to a point where the chamber starts to shrink. So it's that expansion and contraction of the chamber size that draws fluid into the pump and pushes fluid out of the pump. This side of the pump doesn't house the passageways for the intake into the pump or the exit out of the pump. Those passageways are on the other half of the pump cover. But before we go back to the pump cover, let's look at one of these pockets and watch it as it rotates around the pump. Our pump intake is roughly right in this area, and let's pay attention to this pocket. So as the engine rotates, that pocket grows, that creates suction, it sucks in the fluid, and then at some point we get past the intake pocket. Now this pocket is completely sealed off, no way in, no way out. We keep rotating, and now the pocket starts shrinking, so the fluid's going to get pressurized, and that happens at about the same time that we're going right over the passageway that provides the exit for the pump, pushing it out. Then that pocket comes all the way around, and we start the process all over again. And that's just one of the pockets. You got to remember that we've got multiple pockets here, and they're all acting at the same time, going through their suction and exhaust phases simultaneously. Back to our pump cover. This surface here provides the roof or ceiling or the other side of this vane-style pump. As mentioned before, the oil filter goes into this port right here, like so. This port, as you can see, leads up to this section of the pump. Now, if we can imagine our pump assembly on this side, as our vane pocket passes over this slot and the vane pocket is growing as it goes over it, it's going to draw fluid into that pocket. And then as we work our way around the pump, the vane pocket starts shrinking, and it's going to push the fluid out through this slot right here, which leads up into here. And then that high pressure fluid makes its way to various spots throughout this pump housing. So just to recap, the pump is able to suck fluid in and push fluid out, all because of the cavity or the pocket located between any two vanes, the pump rotor, the pump slide, and then the both halves of the pump. That sealed up space growing in size and contracting in size, it enables the pump to suck fluid in and push it out. Now that we've got the basics of how the pump works out of the way, let's talk about how this pump is variable displacement. All pumps, in a sense, are variable displacement. If this pump is turning at 1,000 RPMs, and if you recall, the torque converter drives this rotor, and the torque converter is driven by the engine, they all run at engine speed. So if the engine's running at 1,000 RPMs, the pump is sucking in fluid and pushing it out at that speed. And let's say it outputs X gallons per minute. So it doesn't matter what it is, but let's just call it X. Well, if we go from 1,000 RPMs up to 2,000 RPMs, now we're going to have twice the flow coming out of the pump. So even your traditional automatic transmission pump that is not variable output, it varies in output based off of engine RPM. So at a low RPM, say 1,000 RPMs, it'll put out X gallons per minute. And as the RPMs are increased to say 5,000 RPMs, we can assume that the output's going to be 5 times the amount. What makes this pump special is that when it's at any given RPM, let's pick 1,000 RPMs, we can increase or decrease the output of the pump without changing the RPMs. And how is that done? It's this pump slide here. There's 2 springs that normally live in here. They would be in a compressed state, pushing this slide in that direction. Under certain conditions, oil will enter this cavity right here, and we've got a seal on this side and a pivot on this side that also acts as a seal. And when this cavity fills up with oil, it acts like a large piston, and it actually pushes the slide this direction. The rotor is of course moving right now. Let me throw this on the torque converter so it'll hold that stationary. So now that we've got the torque converter engaged with the rotor won't move as the slide moves. So again, spring pressure is pushing this slide to the right, and as oil comes in and fills this cavity, it's going to push this slide to the left, like so. So let's look at this cavity or pocket between these 2 vanes right here. And see how the volume of that changes. Under spring tension, the volume's closed down. But as oil comes into this circuit and moves the slide over, this pocket gets larger. So that's going to affect both the intake port and the exhaust port, or the intake section or the exhaust section of the pump. So regardless of engine speed, if it's at 1,000 RPMs and we hold 1,000 RPMs, we're able to adjust the input. We're able to adjust the output of the transmission pump. A little later on in the video, we'll talk about where this oil comes from, but before we can do that, we need to talk about the pressure regulator valve and how that works in order for us to understand how this works. One other thing to note about the variable pump design on this 4L60E pump. This can actually save fuel mileage. So as the engine RPMs are increased in your traditional pump, the pump gets to the point where it doesn't need any more fluid, any more flow coming out of it. As the engine RPMs increase, as they do under normal driving conditions, the pump is going to start spinning so fast that it gets to the point where it's outputting more flow than the transmission actually needs. In that case, in traditional pump designs, that excess fluid is dumped off and it flows right back into, or is vented or exhausted to the transmission oil pan. But in the process of that venting, we incur what are called parasitic drag or parasitic losses from the pump. So the beauty of this design is instead of just dumping off excess outputted flow, we just reduce the outputted flow, therefore putting less drag on the engine, less wear and tear on the pump, even at higher RPMs. This is as good a time as any to talk about why we even need this transmission pump in the first place. In other words, why do we need it? What all does it do? What items of the transmission does it serve? When the engine starts, it rotates not only the engine, but it rotates the torque converter. The torque converter rotates the pump. Now the pump starts drawing fluid in and pushing it out. The output of that pump goes in a number of directions, all at the same time. One of the places oil is fed to is this torque converter. The torque converter is filled full of oil, and now the converter can create what's called a fluid coupling between the engine and the transmission. The pump also feeds oil to the transmission cooler that cools the oil. The pump also feeds oil to the planetary gear set and other rotating assemblies, keeping them cool and lubricated. And the pump also feeds oil to all the clutch packs and, of course, the band, which those things act upon the planetary gear set, enabling all the forward gears and, of course, reverse. So, just to recap, the pump is responsible for filling the torque converter. It's responsible for cooling the automatic transmission fluid. It's responsible for supplying what's known as line pressure to all the clutch packs and the band, and it's also responsible for supplying lubrication and cooling to the planetary gear set and, of course, the one-way clutches, the input sprag and the low roller. In the next segment, you're going to get to see how the fluid actually flows throughout the pump and goes to each of these components that we just talked about. So now that we understand how fluid is sucked into the pump and pushed out of the pump, we can now talk about where the fluid travels. So as the fluid exits the pump vanes, it's pushed down into this slot. As the fluid enters this section of the pump, it becomes what is known as line pressure. Line pressure is the highest fluid pressure within the automatic transmission at any given time. I say at any given time because the line pressure varies. On this particular transmission, line pressure can be anywhere from right around 60 psi. When the transmission's, say, in park, engine's idling, there's no load on the engine, it'll be at a low line pressure because at that point there's really no need to apply the clutches really hard. However, if the vehicle is, say, in reverse and it's trying to back up a large hill, line pressure can be jacked up to over 300 psi because in that situation the clutches need to be held very tightly in order to prevent the clutches from slipping. But at any rate, as fluid enters the port, it becomes what is known as line pressure. Once the fluid does enter this port, it can go in one of two directions. In one direction, it goes to the pressure relief valve, not to be confused with the pressure regulator valve. Pressure regulator valve, pressure relief valve. The pressure relief valve is comprised of a pin, like a retaining pin, a large spring, and then there's a large steel ball, and that ball rests against a seat which is made out of aluminum, which is part of this housing, the seat is. But under normal operating conditions, the pressure relief valve is not used. But in the event that there's a problem with this pump and it starts creating more pressure than it needs to, and to the point where it's going to harm or damage the pump, the pressure relief valve will move out of the way. You know, there'll be enough oil pressure acting on that steel ball right here, and it'll push up and against the spring and move out of the way and let fluid shoot past the valve and exhaust back to the oil pan. And while it exhausts, it'll automatically lower the line pressure of the transmission and save the pump from potential self-destruction. So that's one way that the line pressure can flow. Another direction is it comes up through this port. There happens to be an inline filter right here. The fluid travels around that and it can make its way into the pressure regulator valve. The pressure regulator valve is what sets the line pressure. The baseline pressure is set with a valve and a spring. And we'll go into this in more detail in another video dedicated just to this pressure regulator valve. In this video, we're just talking about where the fluid goes. So fluid will come through that filter. It'll make its way into the pressure regulator valve. The PR valve, I'm going to call it for short, the PR valve is hollow at one end. It's got a hole in this section of the valve, and that hole goes through into a passageway that goes up to the end of the valve and spills out right in this little passageway. That oil starts to push the valve down and permits oil flow to flow towards the torque converter. So oil travels from here over into this port, and now it travels all the way around like so and comes down to the torque converter clutch valve. That's this valve here, and oil flow goes to this cavity and this cavity at the exact same time, but depending on which way this valve is stroked, it will send fluid to the torque converter in one of two different ways to either apply the torque converter clutch or release the torque converter clutch. But while we're over here talking about the torque converter clutch valve, a function of the torque converter clutch valve is the lube circuit. This hole here sends fluid after it goes through the converter or bypasses the converter, depending on torque converter clutch operation. Once it passes the torque converter, it's going to go into this lube circuit. Fluid goes out to the cooler, comes back from the cooler, and it enters this port right here, where it makes its way over this direction. And there's a passageway we can't see on this side of the pump, but there's a passageway that leads from here right into the stator tube, and oil makes its way back to the planetary gear sets from there. And in another video, I'll show you all the passageways as to where that goes. Back to our pump. Could go to the pressure relief valve, could go through the filter. Line pressure goes into the pressure regulator valve, which sets line pressure. It bypasses that or goes through it, makes its way to the torque converter clutch and the lube circuit. And as this valve is pushed far enough this direction, oil can actually make its way into this port here. This port looks like it dead ends here, but if we look at the other half of the pump, it actually makes its way down into this area, and it pushes on the backside of that pump slide, decreasing the pump's output. So as the pressure starts rising and we don't need any more pressure, we lower the pressure. One of the ways we lower the pressure is to decrease the output of the pump. Another direction the oil can go is over to this port. This port actually makes its way out to the side of the exterior of the transmission case, where you can hook up a pressure gauge and see what the line pressure is. Oil also flows down this passageway, and it makes its way down to the manual valve and down to a number of other circuits. More on that in another video. If you enjoyed this video, please let me know by hitting that like button. I would love to hear from you. Drop me a line in the comment section down below. If you haven't done so already, subscribe. And don't forget to hit that notification bell so you don't miss any future videos. If you're interested in helping this YouTube channel grow, there are a number of ways that you can get involved. You can find more information in the video description down below. Thanks so much for joining me. I will catch you next time.